Welcome to another session of our class on binomial theory. We have dealt with the Pascal triangle and then we came to the combination method. This time we are going to the factorial approach. Okay, the factorial approach, and I think that the factorial approach will also be so simple for us. You know, as we said, the Pascal triangle sometimes it is lengthy. Okay, especially when the exponent is, let's say, big. Okay, to list all the coefficients is lengthy, and then the combination method, its limitation because of the combination. We don't have, if the exponent is negative, okay, you can't deal with that with the combination. So we are going by the factorial approach, and that one will work for us perfectly, you know, of our question that we are going to do. Okay, so for instance, when we talk about factorial, let's say if I'm giving 6 factorial. 6 factorial is what? The same as multiplying what? Numbers which are less than, okay, positive numbers which are equal to or less than the number 6. So let's say 6 to be 6, as I multiply to reduce it by 5, by 4, by 3, by 2, by 1. Then I'll stop. Only positive number, because when you bring the 0, the whole thing turns to 0. So if it is 5 factorial, the same thing. 5 times 4 times 3 times 2 times 1, 3 factorial, the same thing. Okay, the numbers you are multiplying should be equal to or less than the factorial. Okay, the number with the factorial. So if it is n factorial I'm writing, it will become what? N multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 and so on. All right, you see that because as I'm multiplying, it will be reducing by 1 by 1 by 1. Okay, so let's see how we are going to apply the knowledge of the factorial, and then we also use in our binomial expansion. So we are going to have a plus x exponent n. How do we expand it? So as we know, our first term is always the first term in the binomial, so a exponent n. We have established in both the Pascal triangle and then the combination method that this is always our first, and our last term is also the s exponent n. Okay, so what will be our next term? If it was a combination method, it would have been n combination 1. All right, so here our next term, we will take the n, which is our exponent, then the a will reduce by 1. Then we take the x, it will also take its exponent by 1. Alright, so this will be and this is the same as the combination, because if it was a combination method, it would have been n combination 1. And take note, whatever positive number here I have combination of 1 will be the same number here. So if I have 6 combination 1, it will be 6. 5 combination 1, it will be 5, and so on. So it will be the same n here. Alright, multiply by this as we do this, the exponent by 1, and then the next term x here will come and take that 1 exponent. Okay, so now let's go to the next term. Plus, with the next term, we all introduce the, as the n, we use the combination, the factorial approach for the n. Okay, so it will be n multiplied by 1. Okay, so that is the factorial approach for the n. If it was the combination, that would have been n combination 2. So with the factorial approach n, then we multiply by n minus 1. So as we are going, its multiplication will be reducing. Okay, divided by, we divide here by 2 factorial. All right. Okay, so that here we have our a, n will reduce by 2, so this term will come. Then the x will take the exponent of 2 plus, all right, then we have the n multiplied by n minus 1 multiplied by n minus 2 divided by 3 factorial. All right, then our a exponent will reduce by 1, then the x exponent will take what has reduced here. So I think this with this and this and this, and then the a and the x has no problem, but the issue is just with this small one. Okay, we are going by the factorial approach, so as we are multiplying, it will be reducing. Okay, so we multiply by, so the n becomes the factorial. So multiply n in your first term. Here is the n. In the next term, n, then you multiply by, you reduce the value of the n reduced by 1, multiply by, as we are doing the factorial approach, divided by 2 factorial. Alright, then when you come to your next term, you multiply the n, then the value of the n reduced by 1. So if it is 6, it will be 6 times 5 times 4. Alright, and then and so on. So it means that if I'm going to write my next term, what will be my next term? n minus 1, n minus 2, n minus 3 divided by 4 factorial. Alright, then I have n minus 4. Alright, then my x exponent 4. This will continue and continue to have x exponent what? X exponent n. So it will continue till we have our last term, which is x exponent n. So this is how we apply the factorial approach. And don't panic, it's so simple. We are going to use this approach. I'm not going to clean it, it will be there. We're going to use it to solve one question for us. Alright. So we are going to expand x minus 3y exponent 5. X minus 3y exponent 5. Okay, first thing is going to be x exponent 5, correct? Good. Plus, then this 5 will come. Then we multiply by x exponent 4. Then minus 3y. We take the exponent 1. Alright. So you see, this will be our second term here. Let's go to our third term. Plus, then 5 will multiply by 4 over 2 factorial. Alright. So 5 times 4, it will be reducing, as in this particular place here. Okay. Then x exponent 3. Then minus 3y exponent what? 2. Okay. Then plus, we come to this particular test. So 5 is going to multiply by 4, multiply by 3, divided by 3 factorial. Alright. Then what do we have? X exponent, x reduced by 1 to the exponent what? 2. Then negative 3y exponent what? Exponent 3. Plus, we are not done, plus, then we have what? 5 times 4 times 3 times 2 divided by 4 factorial. Then we have what? X exponent 1, then minus 3y exponent 4. So you see where we have reached here, we have what? We have our last step, because the minus 3y is going to take the exponent of 5 to get our last step. But what would have been the next step? Which would have been 5 times 4 times 3 times 2 times 1 over 5 factorial. What is 5 factorial? 5 factorial is 5 times 4 times 3 times 2 times, which is the same as it. So this one is going to cancel this. Alright. So it means that even if I write this in the next term, it will give us 1. And then x exponent 0 is going to give us 1. So the next term will be our last term, which is negative 3y, all to the exponent of 5. Alright, so I think this is simple and it is understood. So what I've written this long term, this is how you express it. Alright. So now let's do our simplification and we get our terms. So x exponent 5, simple for us. Okay. And then let's multiply. So we have 5 multiplied by negative 3. 5 times negative give me negative what? 15. 15 x exponent 4 and then y exponent 1. So 5 times negative 3 will give me negative 15 and then y exponent 1 x exponent 4. Okay, so then let's go to this place. Okay, so here too, because we have a negative squared, we are going to get positive. So we have 5 times 4 times, this will give us what? Negative 3 squared, which is 9. Alright, 9 divided by 2 factorial. That will give us 90. So plus 90 s cubed y squared. This is what we are going to have here. So 5 times 4 times negative 3 squared, which is 9, divided by 2 factorial will give us 90 s cubed y squared. Then let's come to the next term. We will have 5 times 4 times 3 times what? Times negative 3 cubed divided by 3 factorial, which is 3 times 2 times 1. That is minus 270 s squared y cubed. Minus 270 s squared y cubed. Then we come to the last but 1, which is 5 times 4 times 3 times 2 times negative 3 all to the exponent of 4, negative 3 exponent 4 divided by, so 5 times 4 times 3 times 2 times negative 3 exponent 4 divided by 4 factorial, which is 4 times 3 times 2 times 1. That will give us 405. So plus 405 x and then y exponent 4. X and y exponent 4. Then the last one minus 3 exponent 5 will give us 243 y exponent 5. 243 y exponent 5. So this is what we are going to get. S exponent 5 minus 15s exponent 4y plus 90s cubed y squared minus 270s squared y cubed plus 405xy exponent minus 243 y exponent 5. So this is what we have, and I know you enjoy. Let's solve another question on this, and I believe you understand it perfectly. Okay, so this time around let's solve a question which involves fractional. Let's see. So let's solve let's say like 2s plus 1 over 3 or exponent 7, and let's see, 2s plus 1 over 3 or exponent 7. Okay, so our first term is going to be what? 2s exponent 7. So this will be our first term, 2s exponent 7 plus, then we take the 7, alright, then we have 2x to reduce by 1, and then 1 over 3, so 2s exponent 6, then 1 over 3 exponent 1. Okay, so this will become our second term. Then plus our next term, what are we going to get here? 7, then reduced by 1 times 6 over 2 factorial, then 2x exponent 5, 1 over 3 exponent 2. Alright, I hope you get it. Plus the next term, 7 by 6 by 5 on 3 factorial, alright, 2x exponent 5, sorry, 2x exponent 4, 1 over 3 exponent 3, 2x exponent 4, as this one reduces, this one also increases. So 7 times 6 times 5 over 3 factorial, 2x exponent 4, and then 1 over 3 exponent 3. So that 4 plus 3 will give us the 7. Alright, plus, let's continue. 7 times 6 times 5 times what? 4, all divided by 4 factorial, then 2x exponent what? 2x exponent 3, then 1 over 3 exponent 4. Okay, so as this one is reducing, this one is also increasing, then plus 7 times 6 times 5 times 4 times 3 all over 5 factorial 2x exponent what? 2x exponent 2, then 1 over 3 exponent 5. Okay, we are still not done. Plus 7 by 6 by 5 by 4 by 2 all divided by 6 factorial 2x exponent 1 over 3 exponent 6. Okay, so 1 over 3 exponent. So left with the last step, and the last step will be 1 over 3 exponent 7. For the last term, we have 7 times 6 times 5 times 4 times 2 times 1 over 7 factorial, which is the same as the 7 factorial. Then this one give us 1. Then remaining 1 over 3 exponent 0, which is also 1. Okay. So now let's do our expansion. And let's see what we are going to have. So 2 exponent 7 will give us 128. So this is going to be 128 x exponent 7 plus, since they are all positive, so, and then we have 7 times, okay, so we are going to have 7 times 2 exponent 6 times 1 on 3. That will give us 4 8 over 3 x exponent 6. This is what we are going to have. Okay, then let's go to the next one. We have 7 by 6 by 2 exponent 5 by 1 over 3 squared, 1 over 3 all squared divided by 2 factorial, and that will give us 4 on 3 x exponent 5. Okay, so we come to the next one. We have 7 times 6 times 5 times 2 exponent 4, 2 exponent 4 times 1 over 3 exponent 3, 1 over 3 exponent 3 divided by the 3 factorial, which is 3 times 2 times 1. That will give us 560 on 27 x exponent 4. Okay, so now let's come in here. We have 7 times 6 times 5 times 4 times 2 exponent 3 times 1 over 3 exponent 4 over 4 factorial. That is 4 times 3 times 2, and we are getting that as 280 on 81 x exponent 3. Okay, plus, we are not done yet, 5 times 4 times 5 times 6 times 7 times 6 times 5 times 4 times 3 over times 2 exponent 2 exponent 2 times 1 over 3 exponent 5 over 5 factorial. That will give us 28 on 81 x exponent 2 then plus 7 times 6 times 2 exponent 1 times 1 over 3 all exponent 6 divided by 6 factorial. That is, let me write it here, 14 on 7 to 9 x 14 on 7 to 9 x. Then the last one will be 1 on 3 all to the exponent of 7. And that will be 1 over 2187. So this is our expansion of this 2x plus 1 over 3 all to the exponent of x. This is what we have. All right, this is simple and so easy to do, and I know that you will also give yourself questions and then try on the factorial approach. See you for another lesson still on binomial theorem. Bye bye.